Welcome to Physics 30 Prep Fast Track. In Lesson 1, we're going to learn about some math tools. The three basic tools you'll need to learn about are the metric system, just a review, scientific notation, and significant digits. So just taking a look at some of the math tools, what we mean by this are what are the units, what are we measuring, and how do we describe that. So in science we don't use the imperial units anymore. The British system of pounds and old Abraham Simpson and his so many rods to the hogshead, that's all old stuff we don't do anymore. No pounds, no miles. The metric system is now used in physics 20 and 30 and in most scientific actually hard data gathering. They use the metric system. They'll often explain it to people still using the imperial system because down in the States it's still fairly common to use the imperial. Anyways, the basic units of measurement are the length. For length we use the meter. Alright, and of course we can use smaller or larger units as we'll discuss in a moment. For mass we use the gram, although in physics we usually use the kilogram as the basic unit. And you'll see that the units such as force and work and power and so on are going to be derived in terms of the kilogram and not the gram. And of course for time we use the second. Sometimes we might use the hour or the day or the year or the week depending on our need. But the second is the standard unit. And of course as I mentioned, we use prefixes in front of these basic units to show larger or smaller amounts. In computers, you're probably familiar with kilobytes, megabytes, gigabytes, and even now terabytes. And of course, with the very small, we have centi. A centimeter is small. A cent is based on 100. Millimeter, very small. Milligram, very small. Micro and nano are very incredibly small. As you can see, 10 to the minus 6, 10 to the minus 9. That means 1 divided by a million or 1 divided by a billion. And of course pico would be used to measure the size of an atom if we were measuring length. And so the metric system is a very useful tool in science and you have to have a pretty good mastery of it. On the diploma exam in Physics 30 they do give you a sheet that has all of these prefixes on it and explains a little bit about what they mean. So you don't need to memorize it, but you really should be familiar with most of these units. So moving on to the next tool that we need, and that's scientific notation. When a measured value, whatever that you're measuring, as we discussed on the previous slide, length, mass, time, etc., is displayed, the metric prefixes are used to move the decimal. So 200 meters is a we're not using scientific notation there, that's called standard notation. And of course we move the decimal 3 places to the left from its initial starting point. We move it 3 places to the left, and we at the same time we change the unit from meters to kilometers. And a kilo means 10 to the 3, so that means we can move the decimal 3 places. All right? And that's exactly what we're seeing there. 350 grams could be, if we use the same argument, by putting milli in front of the grams, that means the milli is 10 to the minus 3, we move the decimal from in front of the first 0 to in front of the fourth 0. And micro means 10 to the minus 6, so we move the decimal 6 places. And kilo, because kilo is large, we have to move the decimal the other way. All right, so notice as we use some units, the decimal moves to the right. If we use a large prefix, such as kilo or mega, the decimal place moves to the left. When using prefixes, we usually use or choose a prefix that allows a simple numerical value. All right, so you see the two examples there. 350 grams is better than 0.000350 megagrams. They're the same value, but one is much easier to understand. All right, scientific notation is also used to show large or small numbers. Large numbers, as we recall from kilo, mega, they have a positive exponent, and you're multiplying the base of the number by 10 to the 8, or in the second case by 10 to the minus 31. So 3 times 10 to the 8, that's the speed of light, meters per second, is of course written in scientific notation as 3.00 times 10 to the 8, or 3 with 8 zeros following it. Okay, and small numbers such as the mass of an electron, 9.11 times 10 to the minus 31 kilograms, you can see that that negative 31 has actually moved the decimal place 31 places to the left. All right, making a very small number. And of course, you always have scientific notation with a single digit, 1 to 9, followed by a decimal, and then any more numbers that you want to put. All right, so 2.57 is times 10 to the minus 3 meters is okay, but you wouldn't write a number usually in this form, 25.7 times 10 to the minus 4. They mean the same thing, but they one is accepted form, the other one is not really accepted. Although many people use it, it's really not scientific notation. So the next topic is significant digits, and let's face it, nobody's perfect. I'm not perfect. You're not perfect. That means that no measurement can be perfectly correct. Technology has increased our accuracy, but not to perfection. All right, so when you measure something, the measured value is displayed, such as a length, mass, or time period. Let's say you put a tomato on the scale at the store, and it measures out a certain number of grams, and of course it's telling you the mass of that tomato is 182 grams. But is it 182.7 or 182.6? And if you know the 6 and the 7, is it 182.63 or 182.64? And you can always go another decimal beyond. Is it the nearest hundredth of a gram, thousandth of a gram, 10,000th of a gram, 100,000th, millionth of a gram? We could keep getting smaller and smaller, but of course, to do that, we need better technology, and also we need to use common sense when measuring things. How accurate do we really need to know? The width of a butterfly wing, is it good enough to know it to the nearest millimeter, or do we need to know the hundredth of a millimeter in some scientific study that we're doing? All right, so for example, measuring the thickness of a pencil, we could use a ruler to measure the thickness of a pencil, and we might measure that. If we really look carefully, it might measure out to be 6.5 millimeters, which would be a reasonable estimate with a wooden ruler. However, if you use a micrometer, which is in the picture there, you can see sometimes called a micrometer, but a micrometer we might measure the width of the pencil to be 6.47. Now notice the 6.47 is about the same number, but notice it's accurate to the nearest hundredth of a millimeter, whereas the previous measurement was only accurate to the nearest tenth of a millimeter. More advanced technology, all right? The micrometer is a little more advanced than the ruler, and that allows more digits of accuracy. So when you see a digit, you really should consider that digit in terms of how accurate it is. If it has 7 significant digits or 7 decimals, it must have been measured with something that was very, very accurate. Now sometimes if you do a calculation on your calculator, an example would be 2 divided by 7, you might get a whole bunch of digits in your answer. All right, your calculator shows a whole bunch of digits. Does that really mean that you should put that answer down on paper as the exact answer? Or should you use some other method to indicate the level of accuracy? And that's what we want to do. All right, so we use significant digits to reflect the degree of accuracy of a measurement. Using the correct number of sig digs is considered, to express a measurement is considered an important scientific skill. All right, so if we're all speaking the same language scientifically, then it makes a little more sense to everybody that reads it. We know that if you said 3 sig digs, that means the same to you as it does to somebody halfway across the world. So here's the rules for significant digits, and we're going to follow them. It's not a huge deal, but it's important to be consistent with others. All right? So following these simple rules, all non-zero numbers are significant. What that means is any number from 1 to 9 is considered significant. So if you write down a 9, it means something. And all zeros between non-zero numbers are significant. Trailing zeros are significant, and leading zeros are not significant. Now, what does all this mean? Well, let's look at a couple of examples. In the following numbers, 142.5, these are all non-zero numbers. And so, they have, this number, 142.5, has 4 significant digits. All right, the next one, 63.705, looking at that second rule, all all zeros between 2 non-zero digits are significant. 63.705, the 0 is there, but because it's between 2 non-zero numbers, the 7 and the 5, it's considered significant. So 63.705 has 5 significant digits. Now, this next one, 0.00580, this is where these last 2 rules become important. It says trailing zeros are significant. The trailing 0 is the one at the end of the 8. All right? It's trailing the 8, and so it's considered significant. So because we have the 5 and the 8 and this 0, that's so far 3 significant digits. Leading zeros, it says, are not significant. These 3 zeros out in the front of the 5, they are considered leading zeros. Really what they're doing is just moving the decimal place, and they can be considered not significant. And so this number, even though there are 6 digits, only 3 of them are considered significant. All right? And so that's the deal with significant digits. The thing now to do is get a little bit of practice using the metric system, using scientific notation, and maybe learning a little bit about significant digits, although I find with significant digits it's easy to pick up as you go along. It's not a big deal at the beginning. We're quite forgiving on quizzes and so on, but as you go through the course you should pick up the examples and look at the examples that are given. We always try to use the right number of sig digs, and it's a real simple rule that we'll explain as we go through some of the problems later on. But in your WebCT course, you will be assigned a certain number of pages from your text or workbook, and you can practice up these 3 math tools. And that's it for this lesson.